And now Bruce Yost, if you would tell us a little bit about one of Ames' big things that we focus on as well as small spacecraft.
I'm Bruce Yost. I work here at Ames Research Center, but I'm actually kind of a headquarters person. I'm the program manager for the Small Spacecraft Technology Program, which is a new, is part of a new organization within NASA in the Space Technology Mission Directorate, which is a new mission directorate as of last year. So we're one of 9 programs within the technology group, and we're focused, as the name says, specifically on small spacecraft. And the reason for that is that small spacecraft, by being small, have the connotation or the implication of being lower cost. And that's primarily driven by the fact that you've got when you go to space, there's a lot of things you have to do, the first of which is you have to get off the Earth's surface and into orbit. That means you have to accelerate from 0 to over 17,000 miles per hour. And the heavier, the more mass that you have to accelerate that means more fuel, more rocket, and ultimately more money. So by making things smaller that we want to put in space, we have the argument that says that getting to space should be a less costly endeavor, and we can do things better, more efficiently. But it turns out, so that was the starting tenet of small spacecraft. Space launch is precious, it's very expensive. It's getting a little more affordable. I would say there's a trend there, but it's still not something you just walk out and buy a Lexus or something. It's not quite that easy. But in addition to the low cost part of doing space, we also found out that there are different ways to do space. And small spacecraft are an ideal platform or jumping off point to do that. And by that I mean is if we're not paying a lot of money for the launch, we certainly don't want to pay a lot of money for the spacecraft either. We want to keep everything low cost. And by that I mean we're finding ways to use technologies that already exist to address the low cost aspect of that, of spacecraft. And I'll come back to that a little bit later when we talk about phone sats. The other thing we're looking at with small spacecraft is if you do put one small spacecraft or a number of small spacecraft into orbit, but then you have a team on the ground of 50 people, the cost model doesn't, we're trying to do low cost. So we're trying to find ways to automate and to do things differently than we have traditionally in NASA. And the third thing, or fourth, I forgot what number I'm on. The last thing I'll mention is that by going to small spacecraft, you think that bigger is better, right? Well, going smaller allows you to do things affordably, but also differently than you would in the old traditional NASA sense. And by that I mean, instead of taking, I'll use the classic example a lot of people use, although this is still out in the future. Instead of making a large telescope with a huge mirror on it that is beautiful, makes excellent images of things that we want to see, but it's a monolithic spacecraft. It's big. It has to go up on a very big rocket. It has a lot of cost associated with that. What if you could actually launch that telescope in pieces with little small pieces over time, and have them assemble in orbit, or actually just work together in orbit? They may not even have to physically touch theoretically, but you have now the components of a large asset, but it came from small pieces. There's a lot of things you can talk about how you reduce risk to do that, to actually even make something that's even bigger. I mean, right now we're limited to how much can we stuff on top of the biggest rocket we can make. So that's something like James Webb Telescope. What if you could make that 3 to 4 times as large, but maybe you launch it over multiple launches using smaller pieces? So the technologies to glue all these things together is something that we're interested in as well. I'll just cite real quick the top things that the program is interested in doing. Again, this is a small spacecraft technology program. And I want to make sure I get this right so I don't mess up with the right words. We want to primarily look at things that we can't do normally or routinely. So what are the unique things that small spacecraft can do? So I talked about that already. We also, our main job is to make sure that these technologies get infused into the rest of NASA. And actually into the country. We want, if a company, a space-based company like Loral or somebody can use the technologies we invested in, that's great. But primarily we want to be able to have these technologies wind up in science missions, on exploration missions, contribute to maybe the human spaceflight elements. So we want to infuse things. And the last thing that we really want to do is to kind of give an opportunity for NASA to do things culturally that are different than we traditionally do them. And by that I mean, I'm going to come back to my phone set example. So we had a team of very young engineers that had to ask the question and said, boy, this phone is really handy. It does a lot of things. It communicates, it has sensors on it, I can shake it and it knows when it's being shaken. The power, the processor on there is really powerful compared to the typical processors we fly on spacecraft. Why isn't this a spacecraft? Why couldn't we use this as a spacecraft? So they scratched their heads and got together and actually took a phone, put it into what we call CubeSats, and we launched it in April. We actually launched 3 of them in April. You may have read about it on the web or on the news. So the idea there is, well, it's low cost, so we're leveraging other technologies. We did it relatively quickly. But the other thing that was really interesting is it's kind of open source. If you know how to program a phone, and a lot of people do in the world, then you can program a spacecraft. So there's things about doing things differently, kind of in the Silicon Valley startup mode. How do you do space in a very innovative, try it out and see if it happens type of thing. Take a chance, take a chance on this. Because it's low cost, if it fails, for whatever reason, well, we've only probably lost the amount of hardware that we bought, paid into the system. And if that's really low, you can afford to throw that one away and go try it again, and then try it again, and then improve on it and try it again. And it becomes a very quick-paced development cycle that's really kind of unique, I think, in some areas to NASA. So we're also kind of poking at the cultural way of doing things and thinking about technology and space using these small platforms. Because they are becoming accessible to more and more people. Universities are flying these routinely. There's companies, there's a startup that I went down and saw in San Francisco the other day, and they're making a business case using small spacecraft. So we're really excited to be kind of on that cutting edge of where this is all going as part of the NASA family. And I think I'm out of time.
Very good.
So
maybe one brief question, if someone has something burning. Or we can.
You talked about using several small spacecraft instead of a large James Webb type thing.
Right.
Does the cost work out to be less doing several small as opposed to one big because you end up with the same mass in orbit anyways?
Well, you might or might not end up with the same mass, but you're right. You can certainly put a lot of things like software into a distributed system that would drive your cost very high. But what you save though is if you were, for instance, to lose one of those pieces, you haven't lost the whole mission. You can now either work in a degraded mode or just resupply a marginal piece back to it. Yeah, we have to be careful. You're right, and it turns out that what we're learning is that while the hardware is becoming more and more affordable and easier to put together and integrate, depending on what you want to do with it, the software can become, because these things can do a lot of processing. So now you're to the point where you've got thousands and thousands of lines of code that you got to watch out for because guess what? That costs money too. So it's a good question, but it's a multifaceted problem that we're trying to look at.
Thank you.
Sure.
How do you change the mission objective of the big spacecraft to say 4 smaller? Like you take MSL, we're going to take this budget of space and time and development. We're still going to use that same 18-meter landing system, but we're going to have lots of them. I mean, you have to change the mentality.
Mentality, you're right. So we're a little bit of rebels here because this is not the usual way or the traditional way that NASA has approached big tough problems.
Right, like hardened power supplies.
So hard, exactly. The phones are very attractive, but everybody knows that they were designed for a lot of things on the ground. A lot of environments, dropping them, temperature ranges, but they're not really designed for radiation because we don't live in a radiation environment here on the ground. So there's a lot of questions about will that scale. But back to your Mars example, one of the things we did instead of putting a large, expensive asset down on the ground with, 7 minutes of terror that the JPL guys talk about, why don't we just have the cruise stage go around in orbit and throw a bunch of these small things on the ground, and if let's throw 200 of them onto the ground. If 40% of them reach the surface and work, that's great,
yeah,
right? And now I've got things scattered all over the surface. I don't have anybody at one point. Maybe there's different, there's trades to be made.
Right.
But now I've got a whole different mission architecture than the traditional put everything in one basket type of thing. So that's something we think about as well. So if I answered.
tough stuff.
Yeah, but again, it's
Well,
different.
because you have to take the rock star out of the thing and go, we're gonna, instead of having this really big shiny that's gonna take great pictures, we're gonna do distributed weather satellite that's 10,000 pieces all around the Mars surface.
Something like that, yeah.
Oh, and that's literary.
Well, depends on who you are, yeah. So.
Thank you so much.
Anytime.
Okay.